Hey guys, what's up? So today we're going to be looking at the tetrahedron, guys. It's a cool name, isn't it? Tetrahedron, right? And the volume of a tetrahedron is equal to 1 over 3 A times H. 1 over 3 times A times H, where H is equal to the height of the tetrahedron. You notice this is the height here, the height of this little small pyramid, and A is equal to the base of the tetrahedron. Now the tetrahedron, guys, it's a pyramid, okay? So you can see that it has a height, and the base of this pyramid is a triangle. It's actually a right angle triangle in this example. So you see the right angle here, and right, all the sides of the pyramid are a triangle, including the base, right? So the height is actually different from the base of the triangle, hence why the volume is equal to the area times the height times 1 over 3, right? So A is equal to the area of the base of the tetrahedron, and the area of the triangular base is equal to half base times height. And because we have the base and we have the height, in this case A would be the height and B would be the base for a 90-degree angled triangle. We can work this out, right? But if it's not a 90-degree angle, guys, suppose it's a 120-degree triangle, then we have to use Heron's formula, right? We have to use the square root of S times S minus A times S minus B. So I have to use Heron's formula in the case where the base is not a 90-degree right angle triangle, okay? So you notice, guys, that we don't have the total surface area. And the reason why we don't is because for when we're handling pyramids, we don't usually find the total surface area. It can get really messy and way too long of a question. So it seems that for CXC, they really haven't given you the total surface area for the pyramid. And I really see no need either. It's kind of really too much, you know? So great. So let's do some examples, guys. Let's do 3 examples of the tetrahedron. I think this is really cool. Think about a pyramid and imagine that the base of the pyramid is a triangle. That's pretty amazing. And of course, eventually we can probably look at some real life examples of pyramids for those who love engineering. Scientists still can't explain how the Egyptians and the Aztecs and the Incas as well constructed their pyramids. So it's really interesting. I think pyramids is really an interesting part of mathematics because there's a lot to be awed about when it comes to pyramids, right? It's just amazing, you know. All right, so we're gonna move on to 3 examples of finding the volume of these pyramids. Okay. All right, guys. So we're looking at the 3 examples here for the tetrahedron. Okay. And we can see here that the volume is equal to 1 over 3 times the area times the height. The area is equal to half base times height, or it's equal to the Heron's formula, the square root of S times S minus A times S minus B times S minus C, and H is the height of the tetrahedron. Okay, so let's do the first example. All right, and we need to find the volume. Okay, so let's put that here. Find the volume. Okay. All right, so let's find the volume, guys. The first thing we need to do is find the area of the base of the triangle, right? Which is down here. So A is equal to half base times height. And the reason why we can put half base times height, guys, is because if you look carefully, right? If you look carefully, let's remove this for a second. You can see that it's actually a 90-degree angle, right? They have it here. So this is a right angle triangle. So the base is 4 centimeters and the height is 5 centimeters. Cool. So this should end up being a half multiplied by the base, which is 4 centimeters, multiplied by the height, which is 5 centimeters. All right. So the area should end up being 2 goes into 4 2 times, so it should get 10 centimeters squared. Now we can find the volume for this question. The volume is equal to 1 over 3, right, multiplied by the area, which is 10 centimeters squared, multiplied by the height, right, the height of the pyramid, the tetrahedron, which is 9 centimeters. Okay. Okay, so let's just find the answer for the volume here. So the volume is equal to, this 3 can go into this 9 3 times, and we should get 30 centimeters cubed. All right. So the area is equal to 10 centimeters squared, and the volume is equal to 30 centimeters cubed for this question. All right, guys. Cool. So let's move on to the second question now, and we have the same situation. Let's find the volume, okay, for this tetrahedron. But guys, you notice in this case, it doesn't have the tetrahedron angle as a 90-degree, right? So because we don't have a 90-degree angle for this tetrahedron, right, we don't know the height in the area, right? We don't know the height. And since we don't know the height, guys, then that means that we have to use Heron's formula, okay? So the first thing we're going to do to find the volume, of course, is use Heron's formula. So we need to find the volume, not the volume, sorry, the area of this triangle here. So it would be the square root of S, where S is equal to A plus B plus C, right? Let me just put that over here. S is equal to A plus B plus C over 2. S is a semi-perimeter, all right? And it's equal to 6 centimeters plus 8 centimeters plus 7 centimeters all over 2. Cool. So 6 plus 8 would give us 14, right? And 14 plus 7 would actually give us 21. So it's actually 21 over 2, which is actually 10.5. That's what S is. So 10.5, right, times 10.5 minus 8, right, times 10.5 minus 7 times 10.5 minus 6. All right, guys, that's what we're supposed to get using Heron's formula. Then the area should be the square root of, let's just write it here, 10.5 times 8 minus 10.5 would give us 2.5 times 3.5 times 4.5. All right, so let's just put that in our calculators, guys. All right, guys, so we should get the area is equal to the square root of 413.4375. Okay, so let's just put that in our calculators. Let's find the square root of that. The answer for the area should be 20.33. Okay, and this should be in centimeters squared, right? So the volume should be equal to 1 over 3 multiplied by 20.33 centimeters squared multiplied by the height, which in this case is 10 centimeters. Cool. So we should actually end up with, let's just multiply this by 10, multiply 20.33 by 10, then divide it by 3, and the answer is 67.78 centimeters cubed. Okay, that's the volume. All right, guys. Cool. So the last thing we have to do now is this question here, number 3. We kind of took up a lot of space to do the other questions, so let's really take our time here. So as we can see here in the third tetrahedron, we have to find the volume, right? Find the volume, and we see here that we don't have this third side on this side, right? But we do have the height and we do have the base, right? Because we have a 90-degree angle here, so we can see that we have the height and the base for the area, and we also have the height of the tetrahedron. Okay, so because we have the height of the tetrahedron now and we have everything we need, all we need to do is find A, which is equal to a half base times height. In this case, the base is 5 meters multiplied by 10 meters, and 2 can go into 10 5 times, so the area should actually be 25 meters squared, right? Now the volume is equal to 1 over 3 times the area, which is 25 meters squared, times the height, which is 10 meters in this case. So we just have to put that in our calculators now, guys. We should get 250 divided by 3, right? And the answer is actually 83.33 meters cubed. All right, guys, so that's the volume. So this one was rather easy, okay, even though we didn't get the length of one side. And right, guys, this is really simple. And we're gonna move on to other pyramids now. We're gonna move on to the square-based pyramid instead of a triangular base. Okay, so that's what the tetrahedron is. It has a triangular base. So let's look at a square base for the pyramid instead of a triangle. Cool, guys, so that's it, and I'll see you in the next lecture, and remember to do your best and God will do the rest.